All right, welcome back to Nix Vegas. We are having our next talk by Ethan Edwards, and he's going to talk about FODs and cache and what you can do when GitHub's down. Take it away.
Thank you. Yeah, GitHub being down for like 5 hours yesterday was actually kind of unexpected, but it's a good way to segue this talk. It's been happening more and more often lately, so it looks like this is going to be a pretty good talk for people to listen to. But yeah, thanks for coming, everyone. A little bit about me. My name's Ethan. I'm a free, Libre, and open source software lover. I'm been involved in the Nix community for about 6 years. Big active contributor to Nix packages, have around 400 plus PRs merged, have reviewed thousands of PRs. I think it's like up to 3,000 now. So I spend a lot of time doing Nix. Last summer, I participated in the Summer of Nix program. I was a fellow, and I do infrastructure and Nix at Exa.ai. We're hiring, so if anyone's interested in working for us, we have swag. We'd love to talk to you. We want to hire infra security Nix people. So yeah, come find me, please. And I study computer science and philosophy. But before we get started, have a couple of disclaimers. The views and opinions expressed here are my own and do not necessarily reflect the official policy position or opinions of my employer, university, or any affiliated entity. So yeah, let's get started. So in Nix, oftentimes we need to fetch things. Sometimes we fetch Nix expressions in order to evaluate attributes, or sometimes we also need to fetch things in order to build things, maybe a source tarball. And we do these at two different times, usually at evaluation or build times. So let's talk about build times. When we are fetching things at build times, we usually use what's called a fixed output derivation to do it. We do this because when we do the fetching, we do not want to slow down our eval time by fetching a large tarball. Like for example, here we're fetching SGLang or VLLM, which are hefty tarballs. They're used to run inference code. So you can imagine how many gigabytes or it would take to download those. And we do not want to download the entire tarball into our store at evaluation time. It would slow everything down. So we have this kind of escape hatch in a way that Nix gives us in order to basically create a derivation that we will then build later, and during the build we will download, which is a handy escape hatch. Another thing that we have is Nix is often described as this like hermetic reproducible thing, and one of the ways that it achieves hermeticity and reproducibility is by disallowing the Nix daemon or Nix sandbox from accessing the network, because that can introduce impurities into the final results. But Nix gives us a way to escape the sandbox and to reach the network via the fixed output derivation concept. We need to do this because in order for Nix to really be useful as a build system, we need it to download things like source tarballs. And a common some sets of functions that produce fixed output derivations are like fetch URL, fetch from GitHub, fetch cargo vendor. There are tons of different fetch output derivation functions. I'm sure you use them all the time. They're everywhere in Nix packages and in your internal Nix code. But this is like kind of the simplified definition of a fetch URL implementation, which is a fixed output derivation fetcher. As you can see here, we're pulling standard div and curl as our dependencies, and then we're constructing a function that takes our URL and a hash as arguments, and then we're basically just like passing the URL and the hash to this derivation creator. And then there are these little attributes here, output hash mode flat, which is basically just telling Nix, okay, we're going to produce a single file into the Nix store, and then the output hash algo SHA-256 is how we're going to hash it, and then the actual output hash SHA-256 itself is the hash after we download whatever tarball or URL that we want to retrieve, Nix will take the hash that we pass and verify it to make sure that we didn't download something that we were not expecting. It's a safety and reproducibility guarantee. It's really helpful. Fun fact, fixed output derivations are also content addressed. Fareed, who's actually here and who spoke earlier today, has a really good blog post demonstrating about what this means in practice. Hi, Fareed. I'm talking about your blog. Thank you. It's really cool. Yeah, fixed output derivations are content addressed. So most of Nix derivations are what's called input addressed, which means that the hash in the Nix store, you can see here, is basically constructed by the dependencies that it has. But when something's content addressed, what we care about is not the inputs that it has or its dependencies. We care about the resulting artifact. Here, the resulting artifact is the actual tarball that we're downloading. So when we download it, we take the hash of it and we pass it to Nix and say, hey, check this. If it's correct, then the build succeeds. If anything's changed, the hash will change and the build will fail. And it's an early red flag for us. This is a bit of a demonstration about what it means to be content addressed. If we add something to the derivation, we just echo a meaningless line change. We're not actually changing the result of the fixed output derivation, but we are changing the actual derivation itself. So you can see that derivation path has changed, but the actual build artifact is not. This is very handy. So let's talk about eval time fetching. Eval time fetching is what it sounds like. We fetch something at evaluation. The two common ways to do this are via flake inputs, which you can see here. You declare inputs, or via something like the built-in set of functions to fetch things. Built-in fetch tarball is very common. You'll see it in like old Nix channel non-flake setups in order to fix Nix packages, and then import it into your Nix file. But the issue is that like when we're fetching, we're often fetching from GitHub. And as we know from yesterday, in the past 3 months, in the past 6 months, and basically any time since agents, GitHub's very unreliable. And this is painful because we still need to ship during outages. Our teams need to be able to work. We need to be able to deploy things. But we just can't when GitHub's down. We're also getting rate limited internally by GitHub because we're just building so much. I asked, I queried our build server the other day, and we're doing something like 1,000 builds a minute. At peak, which is a lot. And for a lot of those, we're querying GitHub. So, we're getting rate limited. But yeah, caching here is the solution. So yeah, basically the idea here is very simple. We need a pull through tarball cache. And the architecture's here. You can look at it. Instead of pointing our Nix flakes or our fixed output URLs at GitHub, instead we're going to point it at an internal service that we have that will take a URL, download a tarball, and then serve it to our consumers, the Nix consumers. For the first time that we request a URL, we'll download it from GitHub, and then we'll cache it in an S3 bucket in order to be reused so that we don't have to hit GitHub anymore. So it's really handy. You can see like kind of the logic flowchart here. We're doing a little bit of optimization here in the middle. We're storing what tarballs we've cached in a hash map or a hash set in order to like having to prevent going back and forth to S3 every time. Just a little optimization. And a little bit about the design. We're backed by S3, the greatest cloud service of all time. I don't know if you guys have thought about how crazy S3 is, but like it's strongly consistent over the world. Insane. But we're also kind of making some assumptions here that what we fetch are immutable commits or tags. Once we add a tarball to the bucket, it will never change. This means that the hash will never change, which is a safety guarantee. We also don't support release artifacts for a very specific reason. We're at DEF CON. We all remember what happened with XZ a couple of years ago. The XZ supply chain attack was introduced because someone or a malicious maintainer had injected some malicious code into XZ's release artifact. If the distros would have just downloaded the source instead of the release artifact, we could have avoided this. Some distros did this, some did not. Multiple Git forks are supported. We support GitHub, GitLab, ForkJho, Codeberg, whatever. And then a lot of people have asked me like, fixed output derivations are stored locally, like they're cached. Why do we need this? Yeah, that's true, but an extra layer of caching is nice. Sometimes fixed output derivations don't substitute correctly from your remote store, so this extra layer is useful. And I have a reference implementation here in GitHub. Feel free to take a look. It's written in Rust. It's kind of bare bones, but we'll talk about it later. So here's a demonstration of how it works. You'll see like the older version with GitHub, we fetch a specific tarball with a hash. With our pull-through cache, the implementation or the hash we use is exactly the same, right? We're sharing the same hash between the two different fetchers, where we're just fetching from a different location. And the key thing here is like during this substitution process, this caching process, we don't want to change the tarball at all. We want this cache to be like a drop-in replacement. We don't want to introduce any questions like, is this tarball cache doing something behind the scenes that we don't trust? We want it to be fully transparent. And the bucket layout is roughly like this. We're just creating folders and then dumping the tarballs with their associated hashes or commit hashes or tags into the bucket so that we can download them easy. Very easy to introspect and audit as well. So yeah, let's do a live demo. We are at DEF CON and the internet kind of sucks, so this may or may not work. But here I am running the tarball cache. Let's see. This may or may not work. Here we go. Gonna curl. No. Oh, sorry. It's compiling, of course. Should have pre-warmed. We may come back to the demo. Yeah, we've been using this kind of cache internally for 3 months at Exa. It's worked. We've never had any downtime or outages. We're immune to GitHub outages as well and rate limits. We're protected from force push Git tags, which is unfortunately pretty common. You would think that like once you create an immutable get tag, you would not edit it, but people do it. It's weird. The hash protects this as well, but it's nice to have the extra layer. We actually saw latency in our builds decrease because we no longer have to go and fetch from GitHub. We're fetching from inside an AWS VPC, so it's pretty fast. And we have a list and count of every tarball ever downloaded via metrics, so that's really useful for auditing as well. And we enforce compliance in CI. No one can fetch from GitHub without like permission, which no one does. And yeah, no outages. But yeah, at EXO internally, we don't actually use the version of the open source. We have our own version written in Go for various different reasons. We support some extra things that are EXO specific, like access control, authentication mechanisms, some Cloudflare integration for better analytics, yada yada yada. It's the same thing, same idea. But you just don't want to look at the code. Here's some alternatives that I discussed with people in the community. Jeremy Fleischman, JFly, brought up this like mirror pattern that's new in Nix packages, which is pretty cool. And I think this is actually probably a better solution. But the issue is that it's not very explicit. If we just like introduce this in our code base, no human would understand, and neither would the agents because it's like kind of opaque. So I don't think it's right for us. Same thing with the impure mvars setting. It's just very opaque. S3 and CloudFront is probably a better idea as well, but it would require manual insertion of the tarballs. And the whole idea here is that we don't have to push anything to the bucket; it'll automatically pull. And writing things is fun, so we wrote a microservice. Same thing with like adding an explicit put to the tarballs and not making it pull through. We don't really want to have to worry about what's in the cache and what's not. We want it to just work. Someone brought up varnish to me the other day. It's cool, but it's written in C. It's 2026. Do we really need things that are written in C? I don't think so. Yeah, Fareed says, but I don't think so. But yeah, fixed output derivations are cache and substitutors, but extra safety layer is nice. Sometimes substitutors go down, but we want all the caching we can get. Something interesting I think we should also implement is signing tarballs. Maybe doing this with like a key that we keep on the caching service and then verifying it with a custom function at build time. I don't know, something to look into. But yeah. Thanks for coming, everyone. Thank you again for EXO for sponsoring the talk. We're hiring. Please come talk to me. We have swag, we have shirts, we have goats, everything. The slides are on my website. There's a link. The handout code is on GitHub. And yeah, any questions? No questions? Going once? Going twice? One question. I don't think I can hear you yet.
Oh,
Are we on now?
yes.
Oh, why'd you decide to go with S3 and not like an in-memory cache or like some local cache
Yeah,
disk?
that's a good question. So a local cache would have been fine, but due to the nature of how we deploy these, the cache itself, we were deploying them in pods, which are ephemeral, right? So we don't want to have to like re-download things every time that the pod dies. That's the same reason we didn't do an in-memory cache. Another reason we didn't really want to do an in-memory cache was a lot of the time the tarballs of like are of unbounded size. Nix packages isn't that big. It's like 50 megabits, or sorry, megabytes. But we have like 14 different versions maybe of Nix packages floating around. That would be a lot of memory, or maybe we're downloading something bigger than Nix packages like SGLang or some model or something, be quite large. So I think it just makes sense to stream from S3 rather than trying to store it in memory. Memory will be faster, but expensive, kind of volatile, hard to manage. It just, I don't think it's worth the latency. This doesn't happen that often. Any other questions?